On completion, the students will be able to define Kirchoff's current law, understand Kirchoff's voltage law, and solve problems applying both the laws. Kirchoff's first law, the current law. It is also called as KCL. The total current or charge entering a junction or a node is exactly equal to the charge leaving the node, as it has no other place to go except to leave, as no charge is lost within the node. In other words, the algebraic sum of all the current entering and leaving a node must be equal to 0. That is, I exit plus I entering is equal to 0. This idea is known as conservation of charge. Current entering the node is equal to the current leaving the node. Here there is a node and the current I1, I2 and I3 are entering the node and I4 and I5 are leaving the node. Therefore, I1 plus I2 plus I3 is equal to I4 plus I5, that is equal to 0. Here the three current entering the nodes are I1, I2, I3. All are positive in value. The two current leaving the node I4 and I5 are negative in value. We can also rewrite the equation as I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. Kirchoff's second law, that is the voltage law, KVL. In any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop, which is also equal to 0. In other words, the algebraic sum of all voltages within the loop must be equal to 0. This idea is known as conservation of energy. Starting at a point in a loop, continuing in the same direction, noting the direction of all the voltage drops, either positive or negative, and returning back to the same starting point. It is important to maintain the same direction either clockwise or anti-clockwise, and the final voltage sum will not be equal to 0. We can apply Kirchoff's voltage law for analyzing series circuits. The sum of all voltage drop around the loop is equal to 0. That is, VAB plus VBC plus VCD plus VDA is equal to 0. Find the current flowing in the 40 ohm resistor of the circuit given below. The circuit has 3 branches and 2 nodes A and B and 2 independent loops. Using Kirchoff's current law KCL, the equations is given by at node A is equal to I1 plus I2 is equal to I3. At node B, I3 is equal to I1 plus I2. Using Kirchoff's voltage law KVL, the equations are given as loop 1 is given as 10 is equal to R1 into I1, that is, plus R3 into I3, that is equal to 10 into I1 plus 40 into I3. Loop 2 is given as 20 is equal to R2 into I2 plus R3 into I3, that is 20 into I2 plus 40 into I3. Loop 3 is given as 10 minus 20, that is equal to 10 into I1 minus 20 into I2. I3 is the sum of I1 plus I2. We can rewrite the equation as 10 is equal to 10 I1 plus 40 I1 plus I2 is equal to 50 I1 plus 40 I2. 20 is equal to 20 I1 plus 40 I1 plus I2, that is equal to 40 I1 plus 60 I2. The above equation can be reduced to get the value of both I1 and I2 as follows. I1 is equal to minus 0.143 amps and I2 is equal to 0.429 amps, as I3 is equal to I1 plus I2 The current flowing in resistor R3 is I3 is equal to minus 0.143 plus 0.429. That is equal to 0.286 amps. The voltage across the resistor R3 is equal to 0.286 into R3, that is equal to 40, that is equal to 11.44 volts. Question: state Kirchoff's current law. What is Kirchoff's voltage law?